Hey guys, I hope you're doing great today and welcome to your first theoretical tutorial in this course in Basic Statistics 1 at the Stockholm University. Now this tutorial is going to be about a measure we call the median, which is a measure of centrality that we use in statistics. I'm just going to get right into it actually before I start telling you anything more, but this is what the median looks like. Now when I studied this course that you're studying now, I was kind of freaked out by big formulas like this, and I'm not surprised because they do look pretty complicated if you haven't been working a lot with mathematics and stuff like that. Now the trick to learning formulas that look like this is to check out the different parts that make up the whole. So we learn more about this, and we learn more about n0 and n1 and n and xo. And when we kind of get a feeling for what the different parts of the formula are, we can actually start grasping the whole concept when you add them all together in order to get the median. So this is what we're going to do now. I've created a so-called scatter plot. Now a scatter plot is describes observations which are represented by these dots over here that have different values. So this is observation number 2, and it has a value of 12 years old. So this is years here on our x-axis, and this is number of observations, or frequencies as we say, on the y-axis. Notice that if you count these little dots here, you don't get 25, and the reason for this is that because some of them have the same value, some observations do have the same value of age, they will be placed upon each other. So we have, for example, 2 people who are 12 years old, but they are placed upon each other, so they look like they're one. Just bear that in, keep that in mind while we're going through it. It's not going to have a practical effect on our discussion here for now. It's just for you curious people who do count and become confused about it. So I just want to mention it. So we're going to start by talking about the n. The n is the number of observations in a material, and it is described by the y-axis in this case, where we move up from observation number 1, 2, 3, 4, 5, etc. till we arrive at 25, which is our total number of observations. The median is the middlemost observation in a data set. So what we do is we divide this by 2 in order to find which observation is actually the median. So we do this. And we divide it by 2, we move down here, and we plot our way through the graph until we see here that we end up somewhere in between 18 and 19. And I'm going to guess we end up in around 18.7, but I'm guessing. So this is my, guess based on just visual guessing of what the median actually is. In order to know exactly what the median is, we have to start calculating these other parts of the formula. Now, why are we doing this? Why do we have to calculate the class limit and the number of observations up to the lower class limit, etc., and the class breadth, when it doesn't look like we're dealing with classes here at all? We're just dealing with integers, 12 years old, 13 years old, 14 years old, 15 years old. Well, the reason for this is that if I asked you how old you are and you said, well, I'm 23 years old, I could ask you, how many days old are you? How many hours old are you? How many seconds and how many milliseconds old are you? And you will always be classifying your observation into some kind of scale, which will not be 100% exact. In fact, the scale we're using here is pretty inexact. One person might be 18.1 years old, say they're born in January, and another person may be born in December, and they will be placed in different categories. So the one who's 18.1 years old will be classed in 18, and the person who is 18.9 years old will be called 19. So these are actually classes. So we have to consider, if we're guessing 18.7, which class do we think that it ends up with? Well, I think it ends up in the class 19 years old, because that's just my visual guess based on this drawing that we have here. So we're going to say that it's in the class 19 years old. And we're going to move on, and we're going to calculate how many observations we have up to this limit of 19 years old. Now because we know that the lower class limit of 19 is 18.5, we can count the number of observations we have up to that point. So that is what n0 is here in our formula. We're counting the number of observations up to the class below this median that we have here. I'm going to mention that we're actually just counting visually now from the graph because we haven't calculated the lower class limit yet. But bear in mind that that's what n0 is. It's the number of observations up to our median, but not including our median and the class where the median is located. And 1, on the other hand, is all the observations up to our median and including observations that are in the same class as the median. Now this one ends up in the year category 19, so we have to count this one too. That's N1. X0 is our lower class limit. In this case, it's going to be 18.5. And normally when you're calculating these, you calculate this one first. So you know 18.5, and then you have a raw data set with a bunch of numbers. And then you can compare. You can actually count the cumulative frequency up to the class limit of 18.5. But now we're just doing this visually, so it doesn't matter which order we're doing it in for now. Finally, we need the class width. The class width in this case is going to be 18.5 to 19.5, because everybody who is in between 18.5 and 19.5 will be classified as 19, which makes 19.5 minus 18.5 our class width, and it's going to be 1 in this case. And that makes sense since we're moving up in steps of 1 here. The difference between 11 years and 12 years is 1 year, so that's our class width. Basically, what is happening here? Well, first we find which observation is our median. We move over here, and we find what we get an idea of which class it belongs to. Okay, so we know around which class it belongs to, so we calculate the lower class limit for that class, and we add how far this observation is into the class that we're interested in. So you could say that you're subtracting the value of 18.7, the number of observations up to that, minus that observations before the class, and so you kind of get a feeling for how far into the class we've come. Then you divide this by this number of observations, and you multiply it by the class width. And I realize this can be kind of hard to understand, but this is something you're going to understand better when you do it in practice. So this tutorial should be seen as a background to the tutorials that we're going to work on now, when we're going to calculate this formula in practice and get a better understanding for the different components that it's made up from. And as I said, when you're studying statistics, this is the best way to learn. You try to visualize the formulas that you're working with, and then you put numbers in them, and then you change the numbers. But we're going to do that in Excel. You change the numbers, and you can see how the formula behaves when you put in different numbers for n, or for n0, n1, and w, etc. So I hope you can have some fun doing that, and I will see you in the next tutorials, which will be where we're going to set this median into practice. So have a nice day, everybody. Bye-bye.